Today's lesson is 1.6 Solving Equations Day 2, and what you'll notice about all these examples is that they have square roots in them or different types of radicals once we get farther into these. So I've got some steps over here on the right that I'll give you a second to copy down, and the goal of all of this stuff is that we're going to raise both sides of the equation to the same power. Remember, whatever you do to one side you have to do to the other. And as always in this chapter, sometimes this introduces solutions that don't work in the original problem. Therefore, we do still have extraneous solutions in these examples as well. But notice how these don't have any denominators, so that's not what we're checking for. We're actually checking to make sure it makes the equation work. So I'll talk about that when we get to an example that looks like that. So I am going to skip around because I want to save a couple of these to do in class tomorrow, but I'm going to start with this first one. And what we're going to do on both sides is we're trying to get x by itself, and the only way to get rid of a square root is to square both sides. So that's what I'm going to do first. So I'm going to raise both sides to the second power. Whatever you do to one side, you have to do to the other. And the whole purpose of doing that is that when you square a square root, the whole square root just goes away and you're left over with whatever's on the inside. And then on the right, what do we have to do? We're not just squaring the 2x and the -1, we are actually foiling. So that's what makes this a little bit harder, is that a lot of people don't actually FOIL, they just square both of those numbers, which is incorrect. So when you FOIL that, I'm pretty good at foiling in my head. You get 4x squared minus 4x plus 1, and that's when you FOIL. Okay, so again, remember, you're doing 2x minus 1 times 2x minus 1. And actually FOIL everything out there and combine like terms. Now, again, just like the last video, we have a quadratic here, which means I need to bring everything over to one side and set my equation equal to 0 so that I can solve it. So my 4x squared stays, and I'm going to subtract this 4x from this 4x, which is going to make -8x. And I'm subtracting the 13 over from the 1, so 1 minus 13 is -12. And something pretty easy I could do here before I start trying to factor or do quadratic formula or whatever else, notice that you can divide both sides by 4 here. And we still get 0 on this side, and that gives me x squared minus 2x minus 3. So that made my problem a lot easier. You could still get the same answer if you solved it without dividing by 4, but that's just an algebraic trick, something to save you a little bit of time. So be watching out for abilities to divide and make your numbers a little smaller. This, I think, factors really easily. So we have two different answers of 3 and -1. So here's the thing that kind of, not going to lie, sucks about these problems, is that we do have to check both of them. I don't know if both of them work, if none of them work. Some of you will be able to do this in your head. You're just trying to see if the left-hand side of the equation equals the right-hand side. I'm going to show that work and go through it really slowly on this first one. So I'm going to check 3 first. When I plug in 3 to the original equation, I'm asking myself, does it equal, when I plug in 3 on the left, does it equal to what I plug in 3 on the right? So on the right, 6 minus 1 is 5. I'm just trying to see if this is equal. Square root of 12 plus 13, that's the square root of 25. Does that equal 5? Yep. So I know the 3 works. Now I'm also going to check the -1. Okay, when I plug in the -1 to the equation, again, you might be able to do this in your head eventually. Just be really careful when you're doing that, just to make sure you don't make a silly mistake here. So over here I get radical 9, and here I get -2 minus 1 is -3. -9, or radical 9 does not equal -3, therefore the -1 is extraneous. That's an extraneous solution. This is the only solution. X equals 3. Okay, so sometimes they both work, sometimes one of them works, sometimes none of them work, but it actually is like going through the whole thing and checking and plugging in your numbers, so be careful about that. Okay, you could eventually probably do that part in your head, the checking, but that's what you're checking for, to see if the left side equals the right side. Okay, I do want to skip number 2. We'll do that one in class tomorrow. Let's look at number 3. This one's a little bit easier. This one I've got all kinds of radicals going on, so again, I'm trying to get rid of all these radicals. So what I'm going to do first is square both sides. Okay, and on the right-hand side, you know that that gets rid of the square root, so I just have 5x minus 6 when you square a square root. And on the right-hand side, what it's doing is it is eliminating that big square root, the outside one. So I'm just taking away basically this one when I square. So I still have 3 and 2x plus 3 here. And again, this is if I refer back up to my steps. Where did those steps go? See how I have in here, if there's still a radical after you square both sides, you need to do it again. So that's all we're doing. The point is that we got rid of some of the radicals, we didn't get rid of all of them. So we're going to do it again here. So I still have a radical in my problem. And just remember that when you square both sides, you can't just pick a random thing and square it. You have to square the entire side. So we're squaring all of that, and we're squaring all of that. So the most common mistake that people make here is that they forget to square the 3. But you can't just square the radical and the right side. You have to square everything. So this is actually going to turn into a 9, and the radical for the 2x is going to go away. So maybe put a little star next to that 9, because that is where a lot of people make mistakes. Yes, I will distribute that 9 in just a second. And again, on the right here, we are foiling. So again, when I FOIL that, I get 25x squared minus 60x plus 36. You can verify that with me if you need to pause, but that's what you get when you FOIL. And so from this side, now I'm multiplying both sides by 9. Or I'm distributing the 9, excuse me. And I get 25x squared minus 60x plus 36 over here. Now again, it's a quadratic. It has an x squared in it, so I need to move everything over to one side, so I have 0 on the other side. So that's going to give me 25x squared minus 78x minus 9. Plus 9. Need to know how to subtract. So here I could do quadratic formula. I wouldn't want to do completing the square. Nobody likes to do that. But I think this one factors actually. They're both negative 3's, if I remember correctly, 25 and 1. Yeah, that gives me my 75 minus 3. Okay. So my two answers for x are positive 3 and positive 3 over 25. Okay, so now again, what we're doing is we need to check these. Let's try and do 3 in our head. Okay, so I'm going to do the 3. When I plug the 3 in here, that gives me 6 plus 3 is 9. So the square root of 9 is 3. Multiplied by this 3, that's 9. Square root of 9 is 3. This whole side ends up being 3 when I plug in the 3. And what about the other side? When I plug in this 3 here, that's 15 minus 6, which is 9. And the square root of 9 equals, in fact, 3. So the 3 works. And I'll save you the time for fractions and stuff like this. I know you guys understand the concept of plugging in and checking, but this fraction you would have to use a calculator for, and the left side does not end up equaling the right side when you do the fraction one. So you could either do a fraction or a decimal, but it does kind of suck to plug it in. Just use your calculator, let it tell you what the left side equals, what the right side equals, and they're two different numbers, so that one doesn't work. So the x equals 3 is the only solution for that one. Okay, you can pause the video and check that and actually see that you know how to plug in 3 over 25. That's just kind of a sucky one just because it's a decimal. Okay, example 4. What I like to talk about for this one is if it was a square root, you would square both sides, right, in order to get rid of the radical. But it's not a square root, it's a fourth root. So think to yourself, what do I have to do to get rid of a fourth radical? Well, instead of squaring both sides, the way to cancel that is to raise both sides to the fourth. Okay, so it works for any radical. You've done it with square roots before, but you've probably never done it with other radicals. So that's what cancels my radical on the left-hand side, and I get x squared plus 6x. And 2 to the fourth is not 8, you guys. I see that mistake a lot. You're not multiplying by 4. You're actually raising that to a power. You are raising both sides to an exponent. Okay, so you're not multiplying. That is a common mistake I see. 2 to the fourth, 2 times 2 times 2 times 2, that, my friends, is 16. And again, we have another quadratic, so what we have to do is equal this thing to 0. So I'm going to minus the 16 over, factor it. Factor is pretty easy, which is nice for this one. Positive 8 and negative 2, that gives me 2 answers. Okay, so what I'm going to do here is first I'm going to check the negative 8. These are a little bit easier to check, so I can actually show this work for you guys. When I square negative 8, I get 64, and when I multiply it by 6, I get minus 48. And I'm just asking myself if that equals 2. So what is the fourth root of 64 minus 48 is 16? Does that equal 2? Yepers. So the negative 8 works. I'm also going to check the 2 really quick. You might have already done this part in your head. When I plug in the 2 and square it, I get 4 plus 12. Does that equal 2? Yeah, the fourth root of 16, that's the same thing that we just did. That also works. So in this case, we have two answers that work, negative 8 and 2. Okay, raising both sides of a problem to the same exponent. All right, same thing here. Very, very similar question. Remember that 1/3 is actually a radical. So just remember that this actually means, if you put it into radical language, that it's actually a cube root of 3x plus 7 equals 2. And so if it was a square root, you would square both sides. The fourth root we just did, we would raise both sides to the fourth. This one is a cube root, so we're going to raise both sides to the third. I want you to know, though, you don't have to translate it into this. You can leave it like that, because look what happens. When I raise both sides to the third power, what happens when I multiply these exponents? They cancel, right? That's the same exact thing as raising this over here to the third. We still just get 3x plus 7 on the left. 2 to the third is not 6. It's 2 times 2 times 2, which is 8. And this is a super easy equation to solve after we get rid of that ugly radical. So you don't have to do this translation. It's the same exact thing if you leave it in fractions, because you know what you're supposed to do with fractions like this. A power to a power, that means multiply. And so that's why the 3 and the 1/3 cancel. That's why the cube root over here cancels. So we're just solving this equation. 3x equals, when I subtract 7 from both sides, I get 1. That means x equals 1/3. How the heck do I know if that checks or not? Well, this is actually an easy one. When you plug in the 1/3 to the x, we get 3 times 1/3 plus 7 to the 1/3. Does that equal 2? So 3 to the 1/3, that's just 1. 3 times 1/3, I mean, and then plus 7, that's 8. 8 to the 1/3 is 2. Boom! All right, so that checking, hopefully you'll start to get a little bit more comfortable with doing some of those in your head. Let's see, number 6, let's attack this one. So same thing here. Maybe if you think better in radicals, you could change this one. You don't have to. But again, remember that what this means is if I put this into a radical, 5x minus 2, top number goes inside, bottom number goes out front. This is what we're talking about here. And so what would we do first? I would cube both sides to get rid of the index, to get rid of the bottom number, to get rid of the radical. So what I'm going to do first is cube both sides. And then remember, you know, you're supposed to multiply these exponents right here. So that just gives me 5x minus 2, but I still have the square. Okay, all I did was I canceled the 3's there. So I still have the square. Be careful about that one. This is just a little bit more of a complicated number. 4 to the third is not 12. It's 4 times 4 times 4, which is 64. And then here's a couple different ways to do this. You could FOIL all this out, bring over the 64, and set it equal to 0, refactor it, quadratic formula, whatever. Or, easier way for this one would be to square root both sides. Okay, and so in this case, when we do that, we get 5x minus 2 on the left, but please don't forget your plus or minus when you square root both sides. So we need a plus or minus when you square root both sides. You guys are used to that from the last chapter. So from here, we're actually going to have two different answers. I'm going to go ahead and write my two different equations and solve them separately. So 5x minus 2 equals positive 8. 5x minus 2 equals negative 8. So I'm going to add 2 to both sides on this one. That gives me x equals 2 for my first answer. 5x equals negative 6. X equals negative 6/5 for my second answer. Question is, which one of them works? Do they both work? Do they neither work? So here's what we're going to do. When I take my 2, that one's probably a little bit easier to do in my head. I'm going to plug the 2 into here. That gives me 10. Minus 2 is 8. 8 to the 2/3. So do the cube root first, that's 2, and then square it. You get 4. That one works. You can use a calculator on these. You'll be allowed to use a calculator for these. For the -6/5, you're doing the same thing. I would just plug it into my calculator, and they actually both do work, so you can take my word for both of those. But using a calculator is the easiest way to check to make sure that the left side equals the right side for these kinds of problems. Okay, last one I want to do here is this one. The same thing that I'm going to do first. Remember that this fraction exponent means 10 minus 4x. If you put it into a radical, the top number goes in, the bottom number goes out. So this is just a normal square root. Okay? You can think about it in terms of that, or all I want to do first is cancel this index. So in order to cancel that, what I need to do is raise both sides to the second power. And so in that case, what I'm going to be left over with is 10 minus 4x to the 5th. Remember, those 2's cancel there. That's why I did that. And it equals 32 squared. That's a huge number. I'm just going to leave it as 32 squared for a second. And so now what am I going to do? If this was a square, wouldn't you square root both sides? If it was a cube, you could cube root both sides. In this case, I'm going to 5th root both sides. Okay, so that leaves me with 10 minus 4x on this side. And do you notice that this breaks down nicely? The 5th root of 32, what times itself 5 times is 32? 2 times 2 times 2 times 2 times 2. So 2, and then don't forget this square that's still there. So these actually simplify quite nicely if you remember your properties of exponents. So 10 minus 4x equals 4. Pretty simple equation to solve to finish this one off. Negative 4x equals, if I minus the 10 over, negative 6. X equals 6 over 4, which equals 3 over 2. Let's try checking this one in our head. Plug this 3 over 2 into the 4. When you multiply 3 over 2 times 4, you get negative, you get 6. So 10 minus 6 is 4. And when you square root 4, you get 2. And when you raise 2 to the 5th, you get 32. You can check it in a calculator too if you're not comfortable doing it in your head, that's fine. But the 3 over 2 is an answer that works. Okay, kind of blew through those pretty quickly with a lot of exponent properties, but we will continue kind of talking about this and looking at some more examples in class tomorrow, okay? Thanks for the good notes. See you later.